live.
So welcome to Plug. I'm Russell Sr. I'm the nominal sort of backed into coordinator of this. Like we're 30-some years old now. So we have a speaker tonight. That's excellent. Plug is the Portland Linux Unix group. Who here has never been to one of these before? Okay. Never. Well, that's interesting. Okay, so we have a speaker. That's awesome. That's actually we've been actually continued to have speakers fairly continuously now for a while after the sort of pandemic period. So that's good. However, on a monthly basis, we typically don't have speakers at about this time. So for the next month. And that's also the case here. So we need speakers constantly. If you have anything, either yourself or anybody you might know who has anything they're kind of jazzed about and wants to share with somebody else, that's your opportunity to give a nice talk. So that's just, on the constant. We have a clinic on the third Sunday of the month. It's at what used to be called the EcoTrust building. Maybe it's still called the EcoTrust building. It's in Northwest Portland. Willamette University has graciously provided a space for us there. I'm not sure what, they took over the second floor of the building, or at least part of the second floor, and they have some classroom space there, which is underutilized on the weekend, so they've offered it to us, and we've done that for like 3 or 4 months now, since May anyway, maybe even April. I don't know. It's been a few months. I don't know if we had anybody with a problem come last time.
Some of the helpers had problems.
That's true.
Yeah, what's new?
Yeah, if you don't have any problems, you'll have them at the end of the class.
Yeah, we can give you problems. So there's that, and anybody's welcome. Anybody who wants to help out or just wants to hang out and chat, that's an opportunity to do that. We had a thing in town called Fosse recently, like last weekend.
This weekend, I think.
No,
That was
it's
last.
past now.
Yeah.
Did anybody go to that? Ooh, so give us a report.
I was only there on Saturday. There was like a keynote on that day about a lawsuit in dealing with firmware for televisions and the ability, so it's GPL enforcement.
Yeah.
And I went to a bunch of different talks, kind of all over the place. Saw Matthew Garrett. That was a really good talk.
Cool.
I was sort of like bootloader, chain of trust.
Yeah.
But the talks were kind of, extremely varied. So, but a lot of like law and like
policy,
like licensing and policy.
Yeah.
But there were also technical talks.
Cool. So I kind of neglected to promote them over the last couple of meetings, and partly that was because I'd just forgotten about them, but it was also I was able to forget about them because I'd asked them to provide a speaker, to like promote their own damn meeting, and you were talking about being ghosted before. I got one little nibble and then they just disappeared. So I guess, if you want me to remember, you need to remind me by being a speaker. So that's the Fosse business, and I guess we're ready for the actual speaker. So here's Ian with his topic du jour.
Okay, I've been told to stand here. Hi, which is kind of right next to the projector light. Hi, I'm Ian. I've been going to Plug for a while. I gave a talk a few months ago, so I'm just going to reiterate. If you want fewer repeat speakers, come give a talk. The barrier is very low. You just need to be able to talk. Or sign and have an interpreter. I don't even know. So this talk is, oh, and my goal tonight is to have a talk that's shorter than my previous one, which was 2 hours. So that shouldn't be too difficult. It's on secure shell, SSH certificates, and again, pronouns they, them, this is plugged. We covered all that. Before I talk about SSH, let's talk about digital signatures. This is the slide that I put in, I took it out, and I put it back in. So the usual way digital signatures are presented is you have a message that you send to someone, and you send someone a signature with that message, and they somehow obtain your private, your public key, get that right, and then they can verify that it hasn't been mucked with. SSH does this a little backwards. Rather than assuming the user has a public key, what they do is the message is known by both sides. So when they send the signature, you can then validate the public key. Normally you validate the signature with the public key. SSH validates the public key with the signature. And every arrow on the slide is one way. Just, that's important. So let's talk about secure shell, SSH. This is a simplified diagram, believe it or not. SSH starts with the arrow. The client says, let's start. It gives a list of features it supports. Server sends back basically identical message. Actually, if you're using the same version of OpenSSH, it's almost exactly identical because it's the same software. And I just put that up there for completeness on this abbreviated diagram. Based on the contents of that message, they then start the key exchange. That's what KEX stands for, key exchange. On this diagram, it's an elliptic curve. It can be various types. It's initiated by the client. It says, hey, let's do key exchange. The server says, okay. And some of the things it says is it gives the host, server's host, public key. And this is the point where SSH says to you, the identity of this host is unknown, and you ignore the message and type yes. Certificates help with that problem. The other thing is it sends a signature of what's called the exchange hash, or abbreviated just E. And that's the message that gets signed by the private key, the host private key. So the host has a public private key pair. That's the only thing that's being sent at this point. This is where we check in known hosts for the public key. If it's there, we go ahead. If not, we ask the user. Then, we're actually done with the first phase of SSH. There's 3 phases. Then at this point, if we're doing a shell, or pretty much anything useful on SSH, the client says, okay, I want to authenticate now. I want to send you my public key. It contains the public key, and again, they're going to sign the exchange hash with their private key that demonstrates, I actually own this public key, I didn't steal. And then the server can just check for that key and authorized keys file in the home directory. So, so this is all keys. How do we do this with certificates? Well, are you ready for the next slide? Watch this, watch this. Okay, that's the next slide. I changed key to certificate. I changed some words here, and I changed some words here. So how this works is, SSH2 is very flexible. It basically says you can send whatever you want as long as you've agreed it's a format that you both understand. So instead of a key, we send, we still send a key, but we also send a certificate. That's public information. And so the server sends its public key along with the certificate, and the client can check, it checks the key just like normal, but it can also check the certificate. Why is that useful? Because a bunch of certificates can come from the same authority. See future slide. But you can still put it in the same file. You can also put it in another file, but you can put it, it's a slightly different format in the same file. And then the other direction, so this works both ways, you can do it one way or the other, is again sending the key, but also sending the certificate, and the server checks for the key and authorized keys just as usual, and also can check for the certificate and authorized keys, slightly different format. So, how do we do this? The top bit is the client side. The top bit is making certificate authority. So the certificate authority in OpenSSH land is just another key. You just make a key like normal, SSH keygen -f. That's it, that's all there is to it. Then what you want to do is you want to take public keys.
So, quick question, CA, there's just a file name?
Yeah, this is just fine.
Okay.
Call it whatever you want.
Yeah,
I call
yeah.
it CA because we're going to need it down
Perfect,
here.
yeah.
You take public keys, just like you've already generated, just like the user already has. You send them over to the certificate authority, and you say, sign this public key with the certificate authority. This is the public key, and then these are the weird bits, the I and the N of the weird bits. So the I think that's supposed to be lowercase, and I got autocorrected. Pretty sure that's supposed to be lowercase. I is called the identity. It's required. Command won't work without it. It's used for logging and nothing else. Not really sure why it's required. This -n username will limit the validity to a certain username because you can use the key in more than one way. This is what I just said. And then, so if you have an ID ed25519 and a .pub, you also then have a third file, which is -cert.pub. I love the underscore and the dash, real consistent.
Apparently the capital I is correct.
Oh, okay. So this is all you need to do. On the client side, when you SSH to a server the first time, it says, do you want to trust the server? And when you say yes, instead of trusting that server, it will trust any server whose key has been signed by the CI. So you're actually adding the certificate authority to the node host. And the difference is the line starts with @cert authority. You can add it yourself too, you can look at it. It's just a text file. Footnote, haven't actually tested that, but I'm pretty sure how that works. And then on the server end, this is what you actually need to change. Normally when you run SSHD, the server, the first time it runs in the first boot, it generates the host keys and you never see it, and you never think about it. You actually need to go in, take each key type, RSA, ED25519, whatever other key types you have, sign them with the certificate authority, and then add a host certificate line to the SSHD config for each one of those files. It doesn't have a default location for them.
Okay, I'm
Yeah,
a
go
little
ahead.
bit lost here. So you're adding a certificate authority, which I think, when I think of a certificate authority, I think of a vast building with a whole bunch of worker drones working for hundreds of thousands of sites, and you just joined a community that resembles a bathhouse in San Francisco.
That's an analogy. The term certificate authority is used correctly here. There are certificate authorities like Entrust, DigiCert, Let's Encrypt that are like that. They're very large organizations. They issue a large number of certificates. This is the certificate authority you typically run yourself.
Okay.
You might issue 3 certificates.
So it's one guy in a t-shirt in the basement. Okay, I trust him.
It's you and with a t-shirt.
Yeah.
Or your sysadmin in a corporate context.
Excellent.
So much, much, much smaller. I tried to keep any TLS OpenSSL analogies out of this because that is complicated and this is way simpler. Way, way simpler. Okay, that was the server end, this is the user end. All you gotta do is put the cert next to your key, which is where it goes by default, if you sign it on the same machine. But it's another file, you put it right there, it just works, no changes. On the server side, there's 2 options. This is where the -n username comes into play. So one is, if you're not the server admin, just like you would normally go into the authorized keys file and add your key, you add the certificate authority. It starts with cert authority, but otherwise it's just the contents of this file, just pasted. You can also on a server, in the server wide config, you can add this trusted user CA keys line. Point that to the CA, and then any certificate signed by the CA will be accepted. So you can put this one line in and suddenly accept hundreds of certificates. That's why the -n is important, because if you don't sign for a particular username, then anyone can log in as anyone else. So be careful about that. All right, this is the last slide. So here's the bad news. Well, here's the good news, is this has actually been around since 2010, OpenSSH 5.4. Bad news is it is an OpenSSH extension. It is only in OpenSSH. It took me ages to figure out where it was documented. There's a lot of RFCs for SSH. It's not one of those. It's the separate document protocol.zerkeys on the OpenSSH website, which is really the OpenBSD website. Okay. Questions?
So once you do this, your SSH server will not accept any logins that are not signed by the CA?
That's actually the great part, is everything that worked before still works.
Oh,
It's just extra on top.
okay. So I'm kind of wondering why would you do this?
So the main advantages are just juggling fewer keys. Like if you have a lot of laptops and maybe you're changing keys a lot, you just go to your CA, your C key, sign, and then all the servers that you used to SSH to will continue to accept you.
And your client won't complain when it sees a new host key
in the
if
other
it's been
direction,
signed.
if the host key's been signed, then you don't get that annoying message, you don't need to manage known hosts.
And you don't have to assume that the first host key you get is correct.
You can, if you do your due diligence and you check the fingerprint, you only need to remember the one fingerprint of the certificate authority rather than the one for each of your servers. Yeah.
Say if you want to automate some scripts or something to do, repeated or occasional transfers or something. Is there some agent that you need to run to store the key?
So basically it works exactly the same way. You can run an agent. I don't actually know which agents support the keys, but it's just a file, so probably
it'd be like
most of
some
them.
different agent than like the normal key or whatever or something.
Yeah, you're kind of tiptoeing around the question I had, which is, SSH agent or keychain. I'm not sure where that fits in this space.
Yeah,
I used keychain a lot for moving around servers.
There's Mac keychain and there's GNOME keychain, GNOME keyring, and there's the one just called SSH. I'm pretty sure SSH agent will support this because it's part of OpenSSH. I don't know. I don't use an agent, but it's at the end of the day, if it doesn't support certificates, there's still a key. You can still use the key. The key is exactly the same as before.
So, yeah, I'm still not clear on why this is valuable. So if you tell me what you would do if you had a new laptop.
So if you had a new laptop, that's actually
Or new machine.
probably how I should have done the slides. If you have a new machine, we'll say laptop, so laptop and server. You get a new machine, you make a key just like you would before. You take the public key, you take it to wherever your certificate authority is. You sign it, you take the result back to your laptop, and then you can SSH anywhere you could with previous machines, previous laptops.
Because effectively it's been blessed by the CA.
It's signed,
Yeah.
blessed.
So you can't just, so basically it adds an extra step in addition to the usual just uploading your public key. That doesn't just work because the server's going to say no, it needs to be signed. That's what it
Well,
sounds like.
so you can still upload your public key, it'll still accept it, but you can additionally upload the certificate authority. And then any key signed by that certificate authority is also accepted.
It sounds like you could also restrict it though, right? So that only certificate authority signed keys would work.
Yeah, if you
So-
just
and that
put
would
that.
and that would basically provide that extra layer of security where someone could just start using their key, kind of thing. Or am I not understanding?
You can add your key, or you can add the certificate authority, or you can add both. We'll accept whichever one or both you add.
Okay.
So this is it sounds like it's an alternative to having
It's
to
yes.
push public key up onto the
Yeah,
that
it's, you
server.
push the
So
public key,
if we've got
or you push your cert.
existing laptop that can log into server, and we get new laptop, you either put your public key up on server, or you take public key over here and sign it.
Yeah, it depends
And-
where you
and
render
move
your
it over.
certificate
You
authority.
move the signed one to the new system, and then it doesn't need the public key.
It doesn't, it still uses the public key. It doesn't need it, but it uses it. It's a little, I think it's just a sort of footnote in the SSH implementation. Really, the important thing is you have the private key. I saw some hands. It's you.
Do you have to turn this on the server? Like, what if
Yes.
you don't have root control on the
So
server?
if you don't have root control, you
For it
can
to be
add
turned on?
the certificate authority to your known host file in your home directory. Or authorized keys, add certificate authority to the authorized keys in your home directory. That will just affect your user.
Yeah, I was just.
If you have root, you can add the certificate authority to the server config.
Yeah, I was just thinking that, and I could be wrong, but I thought that in my limited experience that for, say, like accepting a private, public key thing, the regular kind, not the certificate, but that there had to be something that had to be uncommented in the server config that allowed public key authorization.
The server needs a config that says which files the public keys are listed in. That's on by default.
Oh, okay.
It's been on by default for, I think, always.
Okay.
Yeah. Yeah.
So instead of uploading each of your computer's public keys, you just upload a single certificate authority.
Yeah.
Oh, nice.
So if you have like multiple clients and you have all those keys signed, then they won't need to go through that initial confirmation because they'll know that the server is trustworthy because it's already.
So the first time each client connects to the server, you'll still need to accept the server's, either the server's public key like usual or the server's certificate authority. So you still need to do it per host, but it's only one fingerprint to recognize.
If you were deploying a fleet of these things, you just program the certificate authority into each of the client devices, and they'd only have to do that once.
Yeah.
So just for an example of how you might use this, me, and another person in the room manage a fleet of routers. And I got interested when I heard about this some years ago.
And this is your unfortunate news because it's OpenSSH, not Dropbear.
Yeah, so one of the issues is we use Dropbear on the OpenWRT firmware, and that does not support this whole certificate thing. In theory, we could use OpenSSH instead of Dropbear and use this. So what So anyway, I got interested in this whole certificate authority thing at the time, because I thought, oh, this will solve a big problem. We can essentially bless all these devices, these router things, and then the client devices that are connecting, they just have to have registered the certificate authority key, and then we won't constantly be having to guess or try to validate whether or not the thing we're talking to is actually a thing we thought we were talking to, et cetera, et cetera. But when I discovered Dropbear didn't do that, now basically we cook custom firmware for each device, and we actually compute the host keys for those and build them into the image that we're flashing, so that in theory, we've got a list of the public keys already, and we can just pre-deploy that to people as a known host blob, essentially, that they can paste into their known hosts, and then they can know that the thing they're talking to is the...
There are a number of ways to distribute known
Yeah.
Though the DNS is one. I've never seen it done, which is unfortunate, because it's not, well, first you have to distribute them via DNS, and then you need to make sure DNSSEC is enabled or it's useless.
Right.
This is simpler, but you still need to distribute your known hosts. It's just shorter. Okay, everyone's thoroughly confused.
Well, I have a question as someone who always finds ways to break things. How do you test to make sure you configured it right?
Yes, how do you test SSH without locking yourself out? That's a good question. I'd love to hear the answer. You can
Log in
you
again?
can do the keys the normal way, and then you can add the certificates on top, and you can check the log to make sure it's using the certificate.
So there's a varlog SSH that's telling you what it did, and you can do a...
Just when you run SSH, give it the
-v.
for -v.
Yeah.
I think you
Couple
might
of
need 2 or 3 verbose flags, and then so what it'll do is it'll try the key. I know because I tried this for this talk. It'll try the key first. It'll say ED25519, and then it'll say ED25519-cert, and that's how you know it took the certificate instead. So I guess it tries the cert first. So if the cert's still there, yeah, you just kind of not really sure how you test SSH without locking yourself out. Make another user?
Yeah, it's the old...
Kind of a catch-22 type scenario.
If you're ignorant and you don't know whether you're ignorant or not, I guess you just assume you're ignorant.
Well,
actually,
it'll
so
educate.
here's one thing you could do is you could move your key aside, and then if it doesn't work, just give SSH the -I and point it to your key.
You can also specify aliases and whatnot in the SSH config.
-I is easier.
But the other thing is when modern SSH versions, when you're restarting the daemon, for example, if you're setting a new configuration, it doesn't close. Depending on how you have it configured, but by default, it doesn't close existing connections. So if you're already logged in and
If
you
you
know that
open
works,
SSH,
you can leave that terminal
it'll
open.
leave the connection. If you have connection caching or connection sharing, they'll stay up for so much time after you close it. So yeah, you want to make sure it's all.
You just have to keep track of your terminal windows then.
So the certificate authority is on the server?
The certificate of authority is wherever you put it. So
Okay.
I have mine on a little pine board. It sits in a drawer. It's never been connected to a network.
Okay, so
you don't
you
need to go to that extreme.
Because sorry, go ahead.
Basically, access to the certificate authority, which again is just a key pair, means people can start signing things. So you want to keep that secure.
What's the effect of revocation?
You can.
Yes,
You'd
there's
still be able to
revocation.
log in, right? You just wouldn't have the confirmation that it's
I
what you
think
it is?
I think what you do is you can generate a revocation list. Part of the problem is then you need to go everywhere that was accepting the certificate authority and give it the new revocation list. It might be easier just to make a new CA depending on your scenario. Again, revocation list, it should be, I'm pretty sure it's, again, simpler than the OpenSSL version. Another simplification is in TLS land, you can have cert, signing cert, signing cert, signing cert. This is one level. It only goes one level.
What are the problems with running your own certificate authority? I mean, say like you're accessing a remote network that's you don't administer, and how, what ports do you have to have open or?
So the certificate authority is just a key pair. It's just 2 files.
Oh,
Actually, you
okay.
can delete the public key if you want.
Okay.
It's just a private key.
So there's no
just a file.
process involved? Or?
It's just running the SSH keygen with having that file.
Okay, so no service, no service.
Yes, no service, just
okay,
a file.
I'm sending you my file.
So while the service might be a human service, here's my public key, please sign it. Okay, but if it's yourself, then just you take your public key and your certificate authority and you run SSH keygen-I and you get a cert and you use that cert.
And you can rebuild your public key from your private key, right?
Yeah,
Okay.
I almost had a slide with that. It's dash. Why? That might be fingerprint.
Well, it's when I confuse my USB cord with the power cord. And,
It's not that bad. Yeah, no, you can, I guess it is technically on the second slide. You can remake a public key from a private key in any scenario.
and all I need is a purple arrow.
Yeah.
Good.
I got a
On
purple
modern-
marker if you need one.
On modern laptops, the USB cord is your power cord.
Too confusing.
You're gonna upset all the electrical engineers in the room with that USB-C nonsense.
USB-C, Thunderbolt, USB 4,
USB 3.2,
Okay, sorry.
Gen
I'm
1. Yeah,
sorry.
no, don't get me started on USB-C. It's great. It's also terrible.
I don't see the USB plug for the room, so.
Yeah.
I never trust those things anyway. Okay.
Anything else?
Any further questions? I wanted a short talk.
Has anybody done this before?
I have.
Anybody else done it?
And someone at Plug brought this up. I don't know who it was, but thanks. It saved me minutes. I don't necessarily that much, but I do. That was neat. And it's all, I'd say it's all right there in the documentation, but the documentation for SSH keygen is poorly organized. It's SSH keygen does like 17 different things. Half an hour.
There's an SSH keygen-VVVV to explain it to us.
The SSH-VVV, when you actually,
Yes, I understand. I'm saying a keygen that says,
Okay.
okay, dummy, this is what's going on.
keygen only takes the V flag if you also give it the F flag.
It does have a nice man page, kind of.
Yeah, you really.
It has letters.
It's poorly organized because it does a bunch of different things and it
Yeah.
goes in a random order. And you read the section on certificates and you go, okay, I don't understand. Like, I don't get the context. Why do I need to dash capital
It's not
I?
random order, it's alphabetical order.
Just
Oh, wow.
So it's not ordered by use case.
yeah, it's not ordered by use case. It's not. There are flags that only apply with other flags, and they're not next to each other, like V.
Yes.
It's okay. It is there. You just gonna have to read the whole thing.
You can specify a validity interval.
Oh yeah, there's a whole bunch of stuff that goes in a certificate that I don't care about. A start date and end date, they default to the beginning of time, the end of time. You can like turn off X11 forwarding within the certificate if you want to. It defaults to just whatever. Okay, I'm just awkwardly standing up here now. So we're done.
Explain moduli generation. No, never mind. That was a joke.
Don't. There, I explained it. Don't need moduli generation.
Oh, yeah, there's a section all on certificates here.
Yeah.
My son couldn't answer this, but how many nines are there in the end of time?
Well, none, it's hexadecimal. So
All
I think it's like 16 Fs or maybe 32.
Okay.
It's a long time.
64.
It actually says in the spec that that is
Mm.
no
Platform specific.
no end of validity.
It's fun, maybe.
Okay, well, shall we?
Record, shortest talk.
It,